Hello, I believe in the course of studying mathematics, you would have come across equations, you would also come across inequalities, and you have asked to solve equations or solve inequalities. Right, do you know the difference? So in this video, I'm going to show you the difference between solving the equations versus solving an inequalities. Right, so I am a linear equation. So what am I? Yes, if I'm a linear equations, I can be represented such as x plus 3 equals 0. And therefore, the values for x can only be negative 3 because negative 3 plus 3 then give you 0. So there's only one possible answer for x, and that is negative 3. Hey, I represent linear inequality. So how do I look like? For example, I may be x less than negative 3. So if that's the case, what are the possible values of x? Is it only negative 3? Oh no, I can be negative 4, I can be negative 5, I can be negative 6, negative 7.1, negative 7.222, negative 8.3256789, etc., etc., etc. Why is that so? Well, let's look at the number 9 below. Right, so if you are inequality, you can be any number highlighted yellow in color. To the left, any number, but not including negative 3. Right, so do you see the difference between linear equations versus a linear inequality? A linear equations, you can only have one possible values for x. However, for linear inequality, you can have several values. Hey, I'm back. So now we have understood the difference between a linear equations versus a linear inequality. How about quadratic equations versus quadratic inequality? How do we go about solving them? So if I'm a quadratic equations, how do I look like? One example, yes, I could be linear factor x plus 3 multiplied with another linear factor x minus 4 equals to 0. So what are the possible values for x? Yes, there are two possible values for x. I can be negative 3, right, because negative 3 plus 3 will give me 0. 0 multiplied with anything else will give you 0. I can be 4, because 4 minus 4 will give me 0. And 0 again multiplied with anything on the left hand side, on my partner, that is x plus 3, will also give me 0 on the right hand side. So if I'm a quadratic equation, I can have two possible values, right? In this example here, negative 3 or 4. But if I'm a quadratic inequality, how do I go about finding the answer? What am I? Meaning, what are the possible values for x? So today we're going to learn how to solve quadratic inequalities. Alright, so in today's video, you're in for the right thing because I'm going to show you three different methods. Three different methods on how to solve quadratic inequality. Alright, so what is method number 1? Oh, before we talk about method number 1, let's look at the quadratic inequality we need to solve. And that is we need to solve a bracket x plus 3 times bracket x minus 4 more than 0. Alright, so let's look at method number 1. Right, so to do method number 1, we're going to let it to be an equation because we want to find the x-intercept. So the x-intercept here will be negative 3 and 4. And we're going to draw a number line. We're going to use number line to help us solve this quadratic inequality. Alright, so let's label your x-intercept, which is negative 3 and 4. So your x-intercept actually divide the whole number line into three different portions, okay? Right, so the first one is highlighted there in yellow. That is any values that is less than -3. Any values that's less than -3. So it could be -4, -5, -6, -7, so on and so forth. So what we're going to do is we're going to choose a number that is less than -3, and then going to substitute into the two linear factors and see what we get as the answer. All right, so the working has been shown there. I chose x to be -5. I substitute into the two linear factor. I get the products to be 18, and 18 is a positive value, right? So it's not just x equals to -5, it's just any value that is less than -3. So it could be -6, -7. Try it on the own, okay? Don't just believe me. Try it and you realize that the product is a positive value. So I'm going to label that positive. And then I'm going to choose a number between -3 and 4. Okay, any values that's between -3 and 4. I chose x equals to 0. I do the same thing, substitute into the two linear factors, multiply them together. And what do I get? I get -12. And what is -12? It's a negative value. Okay, right. So I'm going to label the blue region negative. All right, the last region is the one that it's more than 4, which I highlighted as pale pink. And choose a number there, which I've chosen it to be x equals to 5. Do the same thing, substitute into linear factors, multiply them together, and we end up getting a positive value. All right. So that means there are 3 different regions. So which one actually is our answer for this inequality? So I have positive, I have negative, I have right. So which one is my answer? Right. So to find the answer, we have to go back to our quadratic inequality, to our questions. We want the products. We want the products of these two linear factors to be a positive value. Okay, we want the value, the products to be a positive value. So therefore, the regions that we need to choose would be any value, any x value that's less than -3. That's what we did just now, right? We choose any value that's less than -3, plug inside your two linear factor, multiply them together, you get a positive value. So my first answer will be anything that is x less than -3. Then the second answer will be anything that is more than 4. Any value that's more than 4, right? We put them into the quadratic, these two linear factors, multiply them together, and we'll get a positive value. Right, so this is method number 1. Pretty easy, right? So now let's go on to method number 2. Right, so method number 2 is still using number line to help us find the answer. All right, so let's examine the quadratic inequality. Now, you want these two linear factors to multiply them together to get a positive value. So what are the possibilities? Just ask yourself, I want a positive answer in the end. I got 2 friends. You see, I got friend A, I got friend B. In the end, I want a positive answer. So what is the possibility? Yes, the possibility is if you are this guy here, let's give you a numerical example, okay? Okay, if you are this x plus 3, if I let x to be 4, so you will have 7, which is positive. You would have 7 minus 4, 3, which is also positive. So positive times positive will give you a positive, right? Which is what you're interested in, right? Then what is the other possibility? The other possibility will be negative times negative. Okay, how is that possible? Let me give you a numerical value, okay? I can have x, I can let x equals to be -5. So -5 plus 3, and then -5 minus 4. Let's see what happened. You will have -2 multiplied with -9. Will give you a positive value. Okay? So in other words, the possibility to get the product to be a positive number, it's you can have the first linear factor to be positive, second linear factor to be positive, or first linear factor to be negative, second linear factor to be negative. Then the next question that you may want to ask me is that, then is it possible to have this guy to be negative and this guy to be positive? Well, I don't think it's possible. It's not possible for x plus 3 to be negative, because if your x plus 3 is negative, Negative means less than 0. So your x must be anything less than negative 3, right? And if you want x minus 4 to be more than 0, then anything x must be anything that's more than 4. So are you able to find a value, okay, that is less than negative 3 and yet more than 4? Of course you can't, right? So this is not a possible combination. Okay, it's not a possible combination. And then maybe you ask me, then how about the other one? How about if I have a positive first here and a negative first? Right, but if you have a positive times a negative, it will give you a negative answer, right? Which is not what you are interested in. What you're interested in, it's a positive product. This one here. What you're interested in is a positive product. Okay, so therefore, these are the two different combinations you can have. Okay, so let's look at the first combination. Both, I like the linear factor x plus 3 to be positive and x minus 4 to be positive. So what are the answer I get? X can be more than negative 3 or x can be more than 4. So if you were to draw the number line, right, if you want it to be more than negative 3 then more than 4, then it must definitely be more than 4, right? Because if I choose a number that's more than negative 3, let's say I choose negative 2, okay, you see, I can have negative 2, right? So for x to be more than negative 3, right, I can choose x equals negative 2. But is x equals to negative 2 more than 4? No. No, right? No. You understand what I'm saying? But if I choose, let's say if I choose x to be 5, 5 is definitely more than 4. So 5 also is definitely more than negative 3. Okay? So combine these two linear factor, right? Then the answer I should get will be x must be more than 4. So that is for the first set of inequality here. Oops. Hang on. That is for the first set of inequality here, right? To get x more than 4. Then for the second set of inequality, we say that it can be it can be negative, so x plus 3 can be less than 0, or x minus 4 can be less than 0. So you end up getting another set of another drawing, number line there as shown. Right, so if you want something to be less than 4, also less than negative 3, then obviously you can only choose it to be less than negative 3. Okay, example. Okay, if let's say you choose a number here, 0. 0 is less than 4, but is 0 less than negative 3? No, it's not. Right, but okay, now we choose a number here. Let's say we choose negative 5. Negative 5 is less than negative 3. Negative 5 is also less than 4. So you combine these two inequality, what do you get? You get x must be less than negative 3. Right, so can you see you get the same answer? You get the same answer as method 1. So you can have x less than negative 3 or x more than 4 as the answer to solve this quadratic inequality. So you get the same answer as method 1. But method 2, usually it's more troublesome. So I would not advise you to use method 2 lah. I would advise you to use method 1 or method 3, which I will show you in the next slide. Alright, so method 3. Alright, method 3 is to use the graphical method. So you need to sketch the curve. Right, to sketch the curve. It's use graphical method, so you need to sketch the curve. So to sketch the curve, you need to know whether it's U-shape or N-shape. So how do you know it's U or N? You just take the first guy here, x times x, to give you x squared. Right, and the coefficients of x squared will be 1, and 1 is a positive value, so this will give you a U-shaped curve. Right, so this is a U-shaped curve. So we need to find the x-intercept. Like in method 1 and 2, find the x-intercept, which is negative 3 and 4. Okay, the x-axis means y is equal to 0. Right, if it's below the x-axis, that means your y value is negative. Right, if you cannot remember, I mean, if you don't understand why, let me draw for you. Okay, right. Do you remember something like this? These are all negative values. So these are all your negative y values. Okay, all this point here will give you. Oh, this is quite a bad drawing. Okay, let me try to draw a better one again. Okay, let me draw. Okay, let's draw. Ayo. Okay, never mind. Try again. Right. So all this point here will gives you. Okay, can you see all this point here? Any point here on this curve, right? Will gives you this part here. This part is where all your negative y values. That's when your y is less than 0. Okay, and then the two curves there. Okay, let's try. Put one point here. Can you see this point here? This point. Can you see that here? This part here will be all your positive y values. Is where y is more than 0. Okay, so what am I interested in? Again, I want my y coordinates to be positive. I want my y coordinates to be positive. So the two regions that I'll be choosing will be the pink color one. So there are two separate curves. So you have two inequality. Hmm? So the first inequality will come from this pink color curve, right? But your inequality will come from the x-axis. Remember, come from the x-axis because you're solving for x, ma. So how do I get x more than 4 leh? You look at this pink color curve. Let's say I want to have this point here. I just draw it down, touch the x-axis. So can you see my x value will be anything more than 4? Likewise, you do it for the other curve. Here, choose any point, drop down, touch the x-axis. So can you see that your x value is anything that must be less than -3? So therefore, your answer are x less than -3 or x more than 4. Okay, which is again the same answer as what we have obtained in method 1 and 2. Right, so there are 3 different methods. So you choose the one you are good, you're happy, what do you call that, not good, that you feel comfortable in, right? And remember it, practice it. And yeah, that ends the video on solving quadratic inequality. Thank you. Okay, so sorry, I think I end the video too early. So let's have a challenge. Time for a challenge. Okay, let's try to solve this inequality. Okay, you can choose any method you want, right? What I would advise you, just choose any method you want, and then you check your answer with what I'm going to do now. So I prefer the first method. I like the first method. So I'm going to use the first method. Okay, so the first method, if you cannot remember the steps, we're going to let it find the x-intercept. So to find the x-intercept means we let, okay, I'm going to change it to purple color. I like purple. I'm going to let it to be a equation to find your x-intercept. So the two possible x-intercepts are x equals to -half or x equals to 1. Then the next thing is that I'm going to draw the number line. All right. Put down your x-intercept. Okay, so remember it actually divided into 3 regions. So I'm going to choose a number here. Okay, wait. Any number that's less than -half. So you can just use -2 lor. So we're going to use sub x to be -2 into your 2x plus 1 and x minus 1. And let's see what is the answer for the products. I will get -4 plus 1, that it's -3. -3. Oh, I'll end up getting a positive value. So I'm going to label this as positive. Okay, and then choose a value here. Anything that's between negative half and 1. 0? Can, right? 0 is between negative half and 1, right? 0, 1. Yeah, so I'm going to sub x equals to 0. So I would have 1 times negative 1, which is a negative value. So here I must label this as negative. Okay, the last region, anything more than 1. Anything more than 1 is easy lah. So let x equals to 3 lor. So we substitute 3 times 2, 6 plus 1. 3 minus 1, 2. 7 times 2, 14. Oh, positive value. Okay, so let's go back to your inequality. So inequality says that, hey, I'm interested to get the products to be a negative value. I want my answer to be a negative value. So which region do I choose? Yes, of course, I choose this region, this guy here. So therefore, my answer, there's only one region there. You see, there's only one region. That's anything that's between negative half and 1. So there's only one set of inequality. So therefore, your x will be anything that's between negative half and less than 1. Can you see the difference between this and the one we did in the example early on? In the example, we have two separate regions, right? The left and the right. So therefore, you have two inequalities. Here, you only have the middle region. So if it's the middle region, you only have one set of inequality. That means your values of x can be anything that's more than negative half and less than 1. Okay, so try using method 2. Try using your, what is called that? The quadratic curve, and see if you get the same answer as me. Thank you.